Well, hello, we're back in the basement lab, and what I'm going to look at now is, now we've done the test to look at the gain of this antenna here. This is the antenna from the Harvard engineering things that go on top of lampposts, and essentially what it is, there's the radio circuit board here, which has a little general purpose RF chip on. And some software to implement the WiMAC protocol, which is very low power but quite surprisingly long range, low throughput communication system for remote control and telemetry applications. So this is the antenna on top. It's 869 megahertz. You can see that on the antenna it's printed on. I have some photos which I took earlier where you can see that a little more clearly. But the antenna has a coating. You can see it shining in the light there, and there's a little bit at the end. You might just be able to see if I can get the focus right. Again, there's some still photos of this which I'll put on the video. But Mark Seal claims that this little blob here is a dielectric lens that's been printed onto the antenna, and he says that the coating on the antenna, which is a conformal coating to stop it stop moisture from affecting it and from corroding it, is a dielectric, and it affects the antenna performance. It might do, but the effect on this scale will be unmeasurable to all intents and purposes. What will affect the antenna, because it's a dielectric on which the antenna is printed, is this circuit board here. This is an FR1, I believe maybe FR2 circuit board, so the dielectric effect of that would have been taken into account when calculating the antenna length and sizing. But again, it wouldn't be very much. But what I thought I'd do is, now we have a 360-degree plot of this antenna and the gain from each side of it. Let's remove this conformal coating and remove a little blob at the end and see if there's a difference in performance. So what I've done, I tried a few different solvents to see if we can remove it. See, it started to come off here, has some success. And the solvent I'm using is this stuff here. It is it's just methanol, and it seems to melt it quite well. So what I'm going to do is just to fill up this little urine sample pot thing. It's not had urine in yet. With this methanol, it's probably getting it all over the floor as well. Let's pour a bit in here to the top. Oh dear, it's just a little bit on the floor. Oh, there we are. Okay. So that's got the methanol in, and what I'll do is find somewhere to stick it really, otherwise it's going to go everywhere, isn't it? What do I have to stick it on? Oh, you know what, I've got a vice, that'll do. So what I'll do is I'll just get that coating off, and then we will repeat the test on the turntable with the antenna and see if there is any difference whatsoever. There we are. So I'll just put this in here, not too far. I don't want to crack it because that would be upsetting, wouldn't it? There we go. So that's going to be sandwiched in that vice there, just so it doesn't move around. There we are. And I'll dip the antenna into there like that, and leave it there for, I don't know, maybe 5 or 10 minutes or so, and then I'll pull it out, and hopefully that conformal coating will just rub off with a bit of rag, and then we'll repeat the antenna test and see if there is any difference whatsoever. Right, so this has been here for, I don't know, about 10 minutes or so now. So let's see if we can get this coating off, shall we? Right. Now you see that is coming off quite nicely now. Super, okay. A bit more work on the end, and get the rig set up, and we'll test it again and see how it goes. Right, so we're back now. The little device here has been cleaned. So there's no longer the coating on. You see a little bit at the end has gone there, a little blob there, and it's no longer shiny. It's just, it's a bit shiny just because the natural thing is shiny anyway, but The conformal coating has been removed, and what I'll do now is reattach this to the turntable here, and we'll start the experiment again and see if there's any difference whatsoever to the radiation pattern of this antenna. Just to make sure it's all correctly oriented, I've got my laptop here and I took the video on, and I'm just making sure that the antenna is exactly the same. So we started off like this with the side without the trace on. So this side is pointing away from the camera, this side is pointing towards the camera. On the test up here, we'll just that there. Okay, there we are. And then the cable, it sort of went around down there. Now what I need to do is to take off this. I'll put some extra bits of Lego on here just to stabilise it with the other test, because obviously there's a slightly higher load on it then. So I'll take all that off. I'm sure it looks. Make sure it's the same as it does on the video. This goes down there like that. There we are, that's what it was like. Excellent. And then the cable in from there, and it sort of went round here, and it locked onto the supply cable here. And the other cable came around the back of the system here, like that, and joined up here. So this is going to be exactly the same as it was before. I had one of these little clips here which clip the cable to this here, like about like there, wasn't it? That's where it was exactly. There we are. So it'll be able to turn around like that, and the cable won't get tangled up anywhere. So we start off like that. Just going to reset the software-defined radio by unplugging it and plugging it in again. And we had the monitor was on top of the radio here, wasn't it? Let's make sure we got the exact same environment we had for the first experiment, just to make sure that there's nothing funny happening. And there we are. Okay, so I will start the test now. It'll take about it takes about 7 minutes to run all in all, and that bit, if I move that map file, because that map file is there, we are, and here we go. The test is going to run. Oh, before running the test, I need to go and turn on the transmitter, don't I? One moment, please. Okay, so we've got the experiment set up now. I've done an initial reading just to make sure that the signal is getting through okay. It is. So I will start the test now. I'll go away as before and leave it so I'm not in the room affecting the results, and we'll see what we get. Okay, so we have the experiment done. The data is on my laptop here. What I've done is I've put in the original data from the last experiment of the antenna just being tested with the conformal coating on the antenna. Just so you can see that that's the graph from the last video. I'll just copy it across. That's the graph of the antenna with this Lego reflector thing on the back to make it directional. And that's the graph there, which has both antenna patterns on. So if I now go back to here, what I'll do is I will get the data. It's just saved from my program in a simple text file. So here's the data here. Select the data, copy it and put it into Excel, and you will see, I've not done this yet, you'll see live what result of this experiment is. So put it in there. I only want the dB values, so that would go here. And how do I add another series to this thing? select data. So it's basically the same data as here. Add it, but it's in column B. So put that there, and B, and the moment of truth. Let's zoom in to the graph here. Are they the same, or does the conformal coating change the characteristics and performance of the antenna? Mark Steele claims in some videos that the coating massively changes the performance and characteristics of the antenna. Let's see. Well, there we have it. It is, I mean, it's almost identical, isn't it, really? Get rid of that silly ribbon thing. There we are. There we are. So that's the difference there. So it is pretty much identical. It's identical all around here, always spot on. There's a little bit of a difference here. It's dropped off a couple of times. But there, so I would say, let's look at what the actual difference is, shall we? That is neg 24.86, 25.7. So it's like maybe a dB off, maybe it's just under a dB. Around here, it's pretty much bang on. But you'd expect, if you claim that it massively changes it, that one will be sort of around here, one will be out here, or there'll be at least, 3, 4, 5 or so dB difference. It's pretty much bang on. It looks almost identical. So the conclusion is then that the antenna with the coating on and the antenna without the coating on are almost identical. So that is another myth debunked. Okay, so we want to look at now what happens if we put a varnishy coating back onto the antenna. So I have it, it's Rustin's Flex Stereo. It looks a bit old and manky. Hopefully, okay, it's ultraviolet and fungicidal protection there, so that should be exciting. So what we're going to do is somehow dip the antenna in this stuff. Okay. Don't want to get this everywhere. So we're going to dip the antenna into this stuff and give it a coating and see what happens. So I'll just pull it off here and do the cable. And when it's got the varnishy smut stuff on, we'll see what happens. Now I need somewhere. I can't quite stick it in there. I won't quite get to the end. Well, you know what I'll do. I will use the pea pot with the stuff in which we used earlier to. Where do I want to put this? I really want to. There we are. That'll do. So I'll stick it in here, and we will do a test with just sticking the end of the antenna into the varnishy gunk in here. Ooh, it's nasty stuff in it. It's curiously, it says it's meant to be clear. Maybe it's a bit too old to be clear. That's fine. As long as it's varnishy, we don't really care. If it isn't clear, it'll show up better on the video, so we can see what it does. Right. So all I'll do is I'm getting into a mess here, aren't we? What can I stick it on? You know what? I'll put it on one of these little clips here. So we'll stick it in into the varnish. There we are. There. And it's going to trip off a little bit. What I'll do now is something to I didn't think this through very well, did I? Okay, well, I'll just stand here for a minute and wait till it dries a bit, or I might hang it up somewhere. But in a minute, I'll show you what happens when it's dry. Okay, there's the antenna. I've just stuck it in this vise here, upside down, so it's going to drip dry now, and we'll see what happens. It's quite interesting. You already see that at the bottom of the antenna here, there's where it's dripping off the end. It looks familiar, doesn't it? But we'll see when it's dry. We'll see what that looks like.